Fighting Blindness Canada's Viewpoint Education Series is designed to help you learn about the latest in vision research, ask your questions, and connect with other people who are living with a blinding eye disease. The session you're about to watch is a recording. To learn more about the research we fund and upcoming programs and events, please visit our website at fightingblindness.ca. Viewpoint is proudly presented by Bayer and supported by Abbvie, Astellas, Beacon Therapeutics, Johnson & Johnson, Novartis, and Roche. Thank you for watching. We hope you enjoy this session and share your thoughts with us in the comment section below. Welcome to everyone, and thank you so much for joining us today at Viewpoint. My name is Morgan Einesen, and I am the Senior Manager of Education at Fighting Blindness Canada. We have three speakers who are joining us who are going to touch on different facets of living with age-related macular degeneration. First up, we're going to be joined by Mo Lalani, who's an individual who's living with AMD, and we're going to talk more about his personal experience. And then our Director of Research and Mission Programs, Dr. Larissa Moniz, will have a conversation with Dr. Peter Campochiaro about the latest developments in research into gene therapy and port delivery systems for AMD. And then lastly, we will have Dr. Alan Cruess join us to be able to answer all of your burning questions about AMD in our Ask the Expert series. So if at any time during today's session you have a question, there's a couple of ways you can share them with us. One, you can click on the Q&A button on your Zoom taskbar and you can type them in. Or if you prefer, you can always email us at education@fightingblindness.ca. And we'll put that in the chat for you as well. So I guess to get started, let's see, Mo, if you're there, if you want to pop your camera on. We can start our chat today. Mo is 79 years old and he lives with wet AMD. He's an engaged volunteer with several NGOs where he shares his experiences of AMD to help educate and support others within the community. Mo, are you there?
Yes.
Hi, welcome. Thank you so much for joining us today. Can you maybe start off today telling us a little bit about your personal journey with age-related macular degeneration? When were you diagnosed, and what were sort of the initial thoughts and feelings you experienced when you found out about your diagnosis?
Sure. Hello, everyone, to the audience. It's a sunny, nice day here in Toronto, so it's an excellent day to be in a webinar. Let me start off. My name is Mohammed Lalani, and I'm called as Mo by most of my friends, just makes it easier. I was diagnosed with AMD wet almost 5 years ago. And at the beginning, I did not know what I was going through. One evening, we were driving to go out for supper. And as I was going to get off the highway, I suddenly realized that the cars in front of me, I was having blurry visions. So I told my wife that I think there's something wrong, we better go home. So made a U-turn and went home, and next day I went to get my eyes checked. Even though I do go for my eyes check every 6 months because I'm a diabetic as well. But more or less this was driven by the incident the previous night. So when I went to my practitioner and I was told that it seems that you are probably suffering from AMD, but he wanted me to go and see a specialist in that field. So I got an appointment at Toronto Western Hospital with Dr. Devinier, and he actually had done my cataracts a few years ago. So I was very lucky that I had an opportunity to be back in his hands, as I had full confidence in his work. So again, they went through the examination, and they indicated that, yes, I do have wet macular degeneration. There was no cure for it, but they would like me to start be on a program where I would be given an injection every month. So that's how it started almost 3.5 years ago. And then just later, around about 3.5 years into it, they suggested that there was a new drug or an injection available, which was more potent and it could be long lasting. So that means that I would not have to go every every month for my injection, but I could then be staggered to go to 2 months. And if my body accepted that new vaccination or injection, then it could be extended to much longer period. So then I was put on this particular medication, and that's what I have been doing until today. So I think the most part that I find is now over the time I've got used to my regular routine of going to the doctors, getting my eyes examined every 6 months, getting my injections, and trying to protect my eyes from direct sun, and also have embarked on a mission to share my experiences with the people in the community, friends, circles, families, and try and convince them to go and get their eyes tested or examined, and if necessary, get on the program. So I think the biggest issue was at that time when I was diagnosed and I could not drive anymore. The decision was made between me, my wife, and my family that it was time for us to move and downsize from the large house we had, which was a triple-story house, and it was viewed that down the road I would have a problem navigating through the house, going up, down the stairs, and then looking after the yard and all of that. So within a very short time, we made the decision, and it was COVID time at that time. So it was a very difficult time because it was difficult to go and visit homes for visual checkup, and also we could not put our house on the market as we did not want people to come through for the open house. So finally, we ended up buying a condominium. We moved into the condominium. We cleaned and did the painting in the old house, and then we put it on the market. And the market was very hot at that time. So we were very lucky that we got the right price. And so it's almost 3.5 years now I'm in this new neighborhood. I'm within walking distance to the Aga Khan Museum, the Smiley Centers, where I go for my regular prayers. And also my doctors and my practitioners are within 10, 20 minutes drive or taking the public transit. Apart from that, I haven't done anything major in terms of major shift in my life, but few things happen which has sort of caused me to start looking at different ways of dealing with this disease. So I use less computers because I find it very difficult to see the screen. So I use uh, tablets, and I use cell phones for all my communications and my checking my emails and what have you. And I've adapted to some of the apps that are there, which helps me to navigate through if there are situations that require any additional help. Apart from that, I think it would be easier for me if there were any questions that I would be able to sort of answer those.
Yeah, Thank you so much. That's great. I really appreciate that you shared both sort of how AMD's impacted your daily life and sort of how important your support system is and sort of some of the strategies and tools that you're using to adapt to any sort of changes that you have. Um, just being mindful of time, and we're going to have our next segment and then maybe we can come back at the end for more questions. But just lastly, do you have any sort of advice or encouragement that you could give to someone who is newly diagnosed with AMD and sort of facing that new journey?
Yes, certainly. I will. I will first give you a brief idea and direction, but I'll also give you an antidote, which brings the message to home. I suggest to people to go for your regular eyes checkup, whether you have or you don't have any inclination that you are losing your eyesight, but have it checked. The second thing I would suggest, especially if you are diabetic, it is more important that you maintain your blood sugar level and have a regular checkup, both for your diabetes and also for your eyes, because in some cases they are interrelated, and quite often AMD is also affected by diabetic. So that is an opener. The second thing I would suggest is don't live in fear. Um, don't shy away from the situation that you may think you have. Let me point out a small antidote that I had recently happened. I met a friend who I had seen for a while at a shopping mall, and he came across to me and said, "Oh, I heard through the grapevine that you're experiencing your low vision." And I said, "Yes." So he said, "Oh, you must have stopped driving." So I said, "Yes, I no longer drive, but I get everywhere. There are many different options." So he says, "I feel that I might be having similar issue, but I don't want to go for a checkup." And I was suddenly surprised to hear his explanation. I said, "Why?" He said, "But I don't want to lose my license. I don't want to stop driving." So that drove the point home that you need to decide what is important to you, your eyes or your flexibility or your comfort of having an access to a car and being able to drive anywhere and wherever. But in my 3.5 years, 5 years, I have become so accustomed to using public transport, Uber, and all of the rides I get with my friends, that I no longer think of having a car and thinking that, oh, I'm missing it. So this is one of the point I would like to bring forward, that don't be afraid, go get your eyes tested, and if at all you have to stop driving, then look for alternative ways to get wherever you want to go to. I have online delivery for all my grocery. I only go to shopping when I can't get any items through my online. And of course, there are some Asian or Chinese items that I may not get through my regular grocery store. Then I would go there and do my shopping. Carrying a magnifying glass, I have different types of glasses for eyes protection during strong sun. And so I have adapted myself. And of course, most cases, my wife is always there with me. So she is always there to guide me. So that I look forward to socializing as much as possible, because I don't want to shut myself in. I try and attend any social events that they are there, whether I can see or I cannot see some of the displays. I go regularly to the Aga Khan Museum just to get out of the house and be with the crowd. I visit the parks, and quite often it's an event where I may go into a museum and I may not be able to read the captions or the labels which are on the products. but then I look for somebody to come and read them for me, or if my wife is with me, she would walk me through. So these are some of the things that I try and share my experiences with. Crossing the road is sometimes a major challenge in some cases where the
Pardon.
roads are very wide. And so, in some places I see they have noise TikToks on your when you're crossing the street, so you can activate those and cross the street. But there's another danger coming, that if we go to what you call electric cars, they don't make noise. So we
Yeah.
will have to be really careful, and I hope there is some legislation being thought about.
Sorry to interrupt. I want to thank
Sure,
you for sharing your experience. It's
no
really
worries.
interesting to hear about all your strategies. And I think that your advice to people about getting those eyes checked, regardless of, what you may have already been diagnosed with or through that fear, I think that's such an important piece that, if you are able to get identified early as having the condition, there's a lot that can be done to help, prevent further vision loss. So thank you so much. We'll probably try to come back at the end if there are some
Okay,
audience questions
thanks, Morgan.
for sharing. I really appreciate that.
Okay, no worries. Thanks.
Okay, so for our second part today, we're going to pass it over to Dr. Larissa Muniz, who's our Director of Research and Mission Programs, who's going to be having a chat about some of the most up-to-date research in AMD with Dr. Peter Campochiaro. Hopefully we can get Dr. Peter Campochiaro and Larissa on screen now.
There we go.
There we go.
Yeah, thank you so much, Mo, and thank you, Morgan. And welcome, Dr. Campochiaro. We're so happy to have you here. So I'll just give a quick introduction to Peter, and then I'm going to give a little overview of wet AMD, just for anybody in the audience who might be new to the field, and then we'll get right into questions with Dr. Campochiaro. So Dr. Campochiaro is a clinician scientist. He is the Astellas Professor of Ophthalmology and Neuroscience at the Wilmer Eye Institute at Johns Hopkins University School of Medicine. And his research really spans the whole spectrum of ophthalmology, from discovery and translational research in the laboratory, as well as being a world leader in clinical trials for both inherited retinal diseases, as well as age-related macular degeneration and other retinal diseases. But today our conversation is really going to focus on some of the clinical trials that he's participated and led in the wet age-related macular degeneration space. And so, again, just to give sort of level set the audience about what age-related macular degeneration is, or AMD, we are talking about it today partly because it is Age-Related Macular Degeneration Month in February, and so we really want to raise awareness of this leading cause of vision loss for people over the age of 55. So, for instance, in Canada, approximately 2.5 million Canadians have AMD. And as Mo just talked about, it really impacts your central vision, which many people on this call will know, making it harder to do activities like reading or driving. And there are the two types of AMD. There's dry AMD and there's wet AMD, as well as an advanced form of dry AMD called geographic atrophy. And because we're talking mostly about wet AMD today, I'll just talk a little bit about the current treatments, which is a drug called anti-VEGF. And wet AMD occurs when you have blood vessels that grow uncontrollably in the retina, and they leak blood and fluid, which can lead to vision loss. And wet AMD, which is also called neovascular AMD, the main first-line treatment right now are these drugs that we're talking about, called anti-VEGF drugs, which are injected into your eye. And the drugs can help slow the growth of blood vessels. And the injections are usually starting every month or two, and then now there are some drugs where you can have longer times in between treatments, but you still require regular injections. And this really gets to the work that we want to talk to Dr. Campochiaro about, because he has been part of some clinical trials that are testing new ways to deliver these anti-VEGF drugs. And hopefully that can either reduce or even eliminate some of the need for some of these injections. So welcome again. And I'll jump right into our first question, which is talking about one of the approaches that you were doing, Dr. Campochiaro, which is called gene therapy. So I was wondering if you could tell us a little bit about what is gene therapy and how might this work for a patient who has AMD?
Thanks, Larissa. Yeah, I think you set the stage very well by your description of what wet AMD is and the current treatments. And as Mo mentioned, he gets injections pretty regularly. And that's the approach because with wet AMD, there's this increased production of this particular protein called vascular endothelial growth factor, which causes blood vessels to grow, abnormal blood vessels, but also causes them to be leaky and leak fluid into the retina, which causes the reduction in vision. And by injecting these proteins which block VEGF, as you mentioned, anti-VEGF proteins, that stops the leakage or reduces the leakage so that the fluid can be resorbed and the vision can improve. But that protein doesn't stay there forever. As a matter of fact, after about 4 to 5 weeks, the protein has exited the eye. And then the leakage begins again and the vision can go down. And so that's why it's necessary to get pretty regular injections. But that's pretty difficult. You know, it's hard to go back every 5 to 6 weeks and get an injection in your eye. So there's been a lot of effort to try to develop new techniques that might have longer lasting effects. And one of them is gene therapy. With gene therapy, instead of injecting the proteins in the eye, what we do is we use a viral vector to inject the gene that makes the proteins that are needed. And so viral vectors are like carriers. The viruses are very good at getting into cells and depositing DNA. And so these viruses that are used for this purpose are engineered and changed so that they don't cause any disease. They don't cause a cold, or they don't cause anything else. They just act as carriers. And so what we do is we inject this viral vector that has the DNA that makes the protein. And usually it's either under the retina or behind the retina or into the vitreous cavity. The most common approach is to inject it under the retina. That's the way that it's been done the longest period of time. And the way that requires an operation, we take a patient to the operating room, we take out the vitreous, and then use a very fine cannula to go down to the retinal surface and inject the viral vector under the retina. The virus then carries that the DNA, the gene that makes the protein into the cells, and then the cells themselves, the photoreceptors and the RPE cells then begin making the therapeutic protein. And so it's constantly produced instead of having to be injected. And many patients who have had this in experimental trials have had control of the leakage long-term and not required injections anymore. Now, it's still an experimental approach. We're still learning about it. And one of the issues with gene therapy is that the virus, although it doesn't cause disease, is still foreign to the body. And so the body's defense system can recognize it as foreign, as not part of the body. And that can cause some inflammation, some reaction to it. And we often control that with topical steroids. But, it's still unknown long-term. We have had patients who have had this now for 4 years or more. And many of those patients have tolerated it very well and have had control of exudation. But there's now 2 ongoing phase 3 trials that, will be definitive in terms of how useful it is. And if it is useful, that will be submitted to the FDA and to the regulatory agencies in Canada. And then it could be an approved product.
I was going to say, it's really exciting. So basically the cells are becoming little factories to make the VEGF drug, I guess. So it's always always there.
That's right.
Yeah, in terms of the clinical trials, so you said you're currently involved in some phase 3 clinical trials, which are usually the biggest clinical trials. Looking at sort of past experiences for the patients who've received the gene therapy before, have any of the patients been able to stop anti-VEGF injections altogether, or is this something where they can maybe have it, but they only have to go in for injections maybe once a year or less frequently? What's been the reaction?
That's a very good question. And there are some patients who have been able to stop injections completely. Probably more than 50% of patients fall in that category. But that was in the phase 2 trial. In the phase 3 trial, there were some adjustments that were made to try to increase the percentage of patients that don't require injections. That has to do with patient selection and the dosage that was given, things like that. So we don't know yet, but in the phase 2 trial, it was more than 50% of patients no longer needed injections.
That's really impressive. And when do you think the results from the phase 3 trial will be released?
So there's 2 phase 3 trials. They always require 2 independent trials. And the first one is almost completed enrollment. Once its enrollment is completed, which should be later this year, then it'll be a year after that for the study to be completed. And then the data will be accumulated and analyzed, and then it will be sent to the regulatory agencies. The second trial is behind the first, and enrollment will probably not be completed until 2026.
So
then
probably
a year after that.
Okay, so probably another like year and a half to 2 years before we start to see results from either of the trials, I guess.
Yes.
Okay. Well, that's really exciting. A really exciting approach. Do you know if there are other sort of similar gene therapies that are being tested, or is the one you're working on the only one currently in clinical trials?
No, that's a good question. There are new approaches which allow injection of the viral vector not under the retina, but into the suprachoroidal space, which is behind the retina. And that can be done in the clinic. So instead of having to go to the operating room and having a procedure, you can have a procedure in the clinic. And there are 2 clinical trials ongoing now testing that approach. There have been improvements in the viral vectors such that there are now viral vectors that can be used with just injection in the eye, just like the proteins are injected. So just like you go in and get one of the injections in the eye, for this approach, you can go in and get the injection of the viral vector. And that there are 2 trials that are just about to start, 2 phase 3 trials for the intravitreal injection approach. So there's a lot of work in this area, and a
lot of really exciting things happening. I'm going to ask you one more question about the port delivery system. I know we have a lot of questions from the Q&A, so then I'll jump to some audience questions. But something else that I know you're working on that's also really interesting is something called a port delivery system to deliver, in this case, anti-VEGF medicines. I was wondering if you could talk a little bit about that approach.
Yes, Larissa. So, there's a lot of different ways that you can provide long-term delivery of these proteins that are needed. One is the gene therapy approach. Another is a implantable, refillable reservoir, the port delivery system that you mentioned. And this requires an operation. It's a relatively straightforward operation in which a small reservoir is implanted into the eye under the conjunctiva, the white part of the eye, and extending through the sclera into the vitreous cavity. And it contains one of the proteins, one of the anti-VEGF proteins, and slowly releases it into the eye over the span of 6 months, actually longer than 6 months. But we know that in 95% of patients, it releases at the therapeutic level for at least 6 months. So as a result, patients get a refill exchange every 6 months. So in other words, it's implanted And then for 6 months, it's releasing the medication into the eye. Patients don't need injections. And then at the end of 6 months, a small refill needle is used to refill the reservoir, and then it's good for another 6 months. So there's patients who have had this now, and this is now an approved treatment for wet AMD. So patients can get this, right away. And patients who have had it really like it because they don't have to come in nearly as frequently. They come in, we see them every 3 months just to check on them in between. But then every 6 months, they get a refill exchange. And most of the patients have done extremely well, had maintenance of their vision, have not really lost any significant vision. And, they really like the fact that they don't have to come in as frequently. And secondly, the refill exchanges are not quite as uncomfortable as the regular injections because you just have to go through the conjunctiva. So it's another approach that allows longer effectiveness and so that you don't have to have injections.
And I could see that this question popped up in one of the chats. The port delivery system isn't available in Canada yet. I know it's available in the United States.
Okay.
But it isn't, the company Roche hasn't brought it to Canada yet. So we are hoping that it will be available here. I was wondering, just thinking about sort of patient experience, you said that patients really like it. Are there any maybe complaints or things that they don't like about it? Because it is having something in your eye, but or do most of the patients have no problem having that in their eye?
So you don't feel it and you don't see it. So patients don't really know it's there.
Okay.
We know it's there because we can look into the eye with a magnified view and see it in the eye. But to the patients, they're not aware of it. The one thing is, of course, anytime you have something that where you do an injection in the eye or you do a refill exchange, you're introducing a needle in, and there is a small chance of infection. So with just the regular injections, it's 0.04%. And and if you look over a long period of time, patients who are getting those injections for many, many years, the cumulative risk is maybe about 0.1%. And that's a similar risk for this refill exchange. So it's not like you can put it in and just forget about it and do the refill exchange every 6 months. We still have to have the patient monitor, and if they get a red eye, to let us know. If they have any pain or anything, to let us know. There have not been a large number of issues. My patients have done extremely well with it and have really enjoyed it.
It's really interesting hearing both of these options and sort of at different stages in the clinical trial. I guess, is there anything else sort of in a similar way that you see out there that's sort of close to the clinic and is trying to use sort of the anti-VEGF drugs, but delivered in a different way? Or are these the two main approaches right now?
No, yeah, Larissa, there are other approaches that are being developed as well. I mean, one is to use small molecules instead of proteins, small molecules that block VEGF receptors. And the problem with small molecules is they don't stay in the eye even as long as those proteins. But what's been happening is to incorporate those small molecules into polymers and then injecting the polymers in the eye, and they slowly release the small molecules that block the VEGF signaling. And it looks like in the early clinical trials that they can also have an effect of 6 months and sometimes maybe even longer. So that's another approach with just an injection in the eye, that there can be long-lasting effects.
Okay, I want to get to some of the webinar questions. The first one was, is there a chance for retinal detachment? I'm assuming when you're doing gene therapy, what are the risks involved there?
Yes, when we do the gene therapy with the subretinal approach, we do the vitrectomy, which is that operation where we remove the vitreous first and then inject under the retina. The risk of retinal detachment is about 1%. So, it's not a high risk, but it is something that is possible with that.
Okay. And for most people who get retinal detachment, is it something that resolves itself over time, or are there often like big complications?
It requires surgery. So I
Okay.
had one patient who developed a retinal detachment. We repaired the detachment, and that patient has done well and maintained good vision over the long term.
Okay. Another question about what you were talking about. Mary Carver asked, what is the reservoir made out of?
Polysulfone, which is a hard sort of plastic. Like you can think of it as the windshield of a fighter plane.
Okay.
It's very inert, it's clear, and the body tolerates it very well. It doesn't, cause any inflammation or problems.
Okay. And now there was a few questions about other types of innovative treatments. So I'm going to ask about a few of those. And if you have comments, please let me know. So one was asking about, can you comment on the effect of red light therapy on AMD?
There is a photobiomodulation treatment that really not a lot is known about, but it's a treatment that is thought to maybe affect the mitochondria in cells. It's not for wet AMD, but it's for dry AMD. And there, the scientific community is skeptical. Okay, it's actually been approved, but there's a lot of skepticism because the studies were not large. They did seem to show some effect, but we'd like to see more data from that before we advocate it.
Okay, so basically seeing a bit more bigger studies before you know if it actually works or not.
Yes.
This question was not from the webinar chat, but we actually get this question a lot about the role that genetics plays in age-related macular degeneration and about getting genetic testing or not. I know that a lot of the sort of large American Association of Ophthalmology and the Canadian Association of Ophthalmology, they don't necessarily recommend genetic testing yet in a diagnostic point of view. So I was just wondering if you could talk a little bit about that.
Yes. So there are inherited retinal degenerations in which a single defect in the DNA causes the retinal degeneration to occur. And Fighting Blindness Canada is very active in that area as well, and retinitis pigmentosa. Age-related macular degeneration is different. It's not a monogenic disease. There's not one single defect that leads to it, but it's a multigenic disease. So genetics plays a role, but it plays a role in a little bit lesser way. There are variants in the DNA that make you more likely to get AMD. And but there's right now no actionable thing that we do based upon the genetics. And that's one of the reasons why it's not recommended to get it. So you could get the genetics, insurance won't pay for it because it doesn't have treatment implications. And you could find out if your risks are somewhat higher. It's not a lot higher, but somewhat higher to get AMD. And that can sort of inform you. But most people feel like, I don't necessarily want to know if my risk is a little bit higher. I'm just going to monitor. And if I get the signs of AMD, I'm going to be seen more frequently by my ophthalmologist.
So yeah, ultimately, a good advice is just to go for your regular appointments And
Yes.
the genetic test gives you a little bit of information, but doesn't really change how your disease progresses or what you can do about it, I guess,
That's
in
right.
terms of treatment. Okay. There's been a few questions also, I think, as a last question about, do you know anything, or are you working in anything that would help restore vision that has been lost? And somebody specifically also asked about RPE stem cell therapy, if you have any comments on that.
Okay, I think Mo described pretty well that in the very beginning of the disease, there is a decrease in vision, and that's from fluid that goes into the retina. With the injections or with these other treatments we've talked about, that can reduce the fluid and improve the vision. So many patients have an initial decrease in vision, and then with treatment, their vision is restored. However, over time, there can be some scarring that occurs. That often occurs because patients may miss some appointments, not come back, not get the injections as frequently as they should. And when that happens, the disease reactivates, you get fluid, but then also if it's untreated, you get migration of cells into the retina, which causes scarring. And that scarring causes permanent loss of vision. So there can be permanent loss of vision from the wet AMD. And sometimes, even with regular treatment, that can occur. Although most times we are able to keep the vision quite good with appropriate treatment. However, the dry AMD, as you mentioned, can progress to geographic atrophy. And that means that sometimes the cells die, and that results in permanent vision. Stem cell therapy is an approach to try to replace those cells. However, it's only used for patients who have really lost a lot of vision because we don't know that much about it. And so it's really experimental. And so there are some clinical trials testing it in patients with geographic atrophy, but it's for patients who have really lost a lot of vision. It's not ready for prime time just yet.
Okay. I think that was a lot of good information. And one last question. We had a question about, which is also something that I wonder a lot about, is, do you know, what is the information or data around why some patients stop responding to anti-VEGF therapies?
That's a very good question, Larissa. So we do see that most patients in the beginning of the disease respond very well to the injections. Not 100%. There are some very small percentage that don't respond ideally. And then over time, particularly if patients don't get regular injections, the injections may not work quite as well. And we don't know for sure why that is, but we surmise that it is due to production of other factors in addition to VEGF that the proteins don't block. And so there are other things that cause leakage in the retina in addition to VEGF. And over time, they may become a little bit more in some patients. But most patients maintain their effectiveness with anti-VEGF long term. Now, I saw someone mention in the chat about Vabysmo or faricimab. This is a bispecific antibody that blocks both VEGF and angiopoietin-2. And angiopoietin-2 is a factor that downregulates the effect of other factors in addition to VEGF. So sometimes patients who are not quite as responsive to the injections, when they're switched to Vabysmo, may have a little bit better effect. Not always. And there was the mention of, maybe it lasts a little bit longer. Sometimes a little bit longer, but not always.
Okay. Well, we have so many questions, and I know also Dr. Alan Cruess is here to answer some more. So I just really want to thank you, Dr. Campochiaro, for joining us today and telling us all about what's a really exciting sort of series of clinical trials that are going on now that could really sort of change how patients are treated in the near future, it looks like.
Oh, you're very welcome, Larissa.
Yeah. Thank you very much. And I'm going to call on Morgan now and Dr. Cruess to come on for the Ask the Expert session.
you, Larissa, and thank you, Dr. Campochiaro. That was fantastic. I always love hearing about all the research that's happening, and just sounds like some really promising things coming along the line here. So, Dr. Cruess, thank you again for being here. We have so many questions already. Just a reminder, you can pop those into the Q&A box, or you can send us an email at education@fightingblindness.ca. All right, let's see where to start. So, well, I guess I should say to welcome Dr. Cruess. Dr. Cruess is a professor in the Department of Ophthalmology and Visual Sciences at Dalhousie University in Nova Scotia. Dr. Cruess's main research interests are in clinical trials of new therapies for age-related macular degeneration, diabetic retinopathy, and retinal vascular occlusion. So welcome, Dr. Cruess, and maybe we could start off. We've had a few questions about dry AMD versus wet AMD, and asking, will dry AMD always progress into wet AMD?
Not always, no. First of all, I'd like to thank Peter for coming too. It was really lovely to see him again and hear him. The work that Dr. Campochiaro is doing is groundbreaking, and it can take a decade or so to go from development to the clinic. And I spend most of my time now actually looking after patients, not so much doing research as he is doing. So what I'm going to be speaking to is really my daily day-to-day experience. The answer to the question is no. Think about, I always tell people it's like a Venn diagram. If you think about a circle of dry AMD and there's a circle of wet AMD, and some people have the circles overlapping, but not everyone who has dry AMD will progress to the neovascular or wet form of the disease. Dry AMD by itself is very, very slowly progressive, sort of almost inexorably progressive. And as you know, there are some complement inhibitor drugs now that are being A, investigated, and B, approved. We have one that failed approval in Canada and in Europe, but is available in the United States. And there's another one, a complement factor 5 inhibitor that's is being looked at now in Canada. So we're hoping that that one will be successful. And there are other drugs in the pipeline. I'm involved in the initial phases of other research in this area. So the answer is no, not always, but monitoring, it also sort of speaks to the monitoring aspect of it, that it's very important to monitor patients with dry AMD for any signs of conversion.
Yeah, so there's a lot of questions here about dry AMD as well today, and I just want to mention that we will have a dry AMD specific webinar later in the year. So we are focusing today on wet, but just maybe to answer a bunch of different questions, are there anything, if you're diagnosed with dry AMD, is there anything that you can do to treat it or slow the progression of that to try to prevent it from advancing to wet AMD?
Well, I think, I always tell my patients that the closer we can get to a Mediterranean diet, we're helping ourselves out in terms of a diet rich in antioxidants, rich in colored vegetables, less red meat, so on. But the two clinical trials from the National Eye Institute that did show a benefit of zinc and antioxidant vitamins in the form of various preparations that are available. One's Preservision, one's Vitalux, and there are others that will, I sort of view those as icing on the cake. If the first thing is getting nutrition right and then adding in the zinc and antioxidant vitamins. And that has shown a significant slowing of the progression of macular degeneration, of dry macular degeneration.
Thank you. And we've also had some other questions about other treatments. So for example, in the chat, Judith asked about laser treatments. Are these an effective treatment for wet AMD?
Well, my original clinical trial experience was with laser treatment of wet AMD, and my clinical trials were sort of spin-offs of the macular photocoagulation study group from Hopkins. And that was sort of an experience that we had through the 1980s. The problem was that only about 10% of patients with wet AMD had neovascular or abnormal blood vessels that were eccentric enough from the central part of vision that could benefit from laser photocoagulation. So the answer is really laser treatment by and large has been supplanted in AMD by the anti-VEGF era, the anti-VEGF injections that Dr. Campochiaro addressed.
And so maybe shifting a little bit to sort of, I'm seeing a bunch of questions about sort of what causes AMD, what are the risk factors for AMD? So are there certain things that make you more likely to develop it? There's been mention of weight, blood pressure. I think someone mentioned smoking. What things who is at risk for developing AMD?
Well, age is the biggest risk factor. I mean, if you take the overall prevalence in a North American population, it's probably about 1 to 2%, but if we're in our 80s, it's probably about 15%. So as the decades move on and we go from our 70s to our 80s to our 90s, there is an exponential rise in the prevalence of AMD. The biggest I mean, we're all getting older day by day, but the biggest modifiable risk factor is smoking. If the average age of the presentation of wet AMD is in our mid-70s, smoking probably reduces that average age by about 10 years. It triples or quadruples the risk of wet AMD. So of all the things that we can do for ourselves, stopping cigarette smoking is probably the number one modifiable risk factor that we can do.
I had a question sort of related to that. Is there any research that you know of being done on sort of the prevention side of AMD versus treatment after the fact? So any research to prevent it from happening in the first place?
Well, I think that a lot of the work that Dr. Campochiaro was addressing, getting at, as we understand the polygenetic variants of AMD better, then we can target some of the genetic defects more specifically that we know are more likely to produce AMD down the line. So that, as we sort of explore genetically driven diseases, we get more and more refined genetic sort of diagnostic correlations, and then we can really start to hone our targets. And that's why he was mentioning, a monogenetic disease like certain types of rod cone dystrophy or RP, can be targeted now with gene therapy, but we're not quite there with AMD yet. So stay tuned, kind of thing.
So there was another question here about you mentioned some of the vitamins, especially zinc and like the Arids, Vitalux, those things. So one of the people in the chat has said that they were told to avoid zinc and that they can't take the Arids too because of that. Do you have any thoughts about that or recommendations for other vitamins that would be useful?
Well, if they're allowed to take zinc by itself, that would work. Most of the effect of the ARIDS trials, ARIDS 1 and ARIDS 2 trials from the National Institute were driven by the zinc supplementation. I guess as we get age, we tend to be relatively zinc deficient. So that would be one option. And it would be interesting to know where the background of that person's story and where the information is that they've received, how it was developed. I mean, there was Dr. Campochiaro kind of alluded to it a little bit. There was some controversy about the genetic subtypes and certain supplements, and I think that's kind of been laid to rest. The approach from the American Academy and from the Canadian authorities has been to say no, genetic testing isn't useful because we can't modify. And don't forget that the results of the ARIDS trials were broadly based with more than 4,000 patients, so that all these different subtypes would have been included in that.
Yeah, that's really interesting. It's a good question. We get it all the time, and I always refer people to talk to your eye doctor as well, right? About what is working for you and what is the best.
Been lurking around for a
Everyone's
long
different.
time.
Yeah.
Yeah.
So we've had a lot of questions about how AMD might interact with other eye conditions. So maybe we could talk a little bit about that. So, for example, someone here is asking, does having glaucoma affect age-related macular degeneration?
Not directly. I mean, you mentioned hypertension. I think I might say one thing about hypertension as an introduction is probably uncontrolled hypertension can drive wet AMD, and there's evidence from the Hopkins group, from the macular photocoagulation study group, about the fact that hypertension predisposed patients to recurrence of their wet AMD. So I think that getting the blood pressure under control is always a good idea. For me, my glaucoma patients, I treat very carefully, because the concern has been, there have been various times when we've been concerned about there's a little spike in pressure when one injects a small volume into the eye. Certain patients will have a little spike in intraocular pressure, and then slowly it tapers down. And the question has been, all these little spikes in pressure over time, do they inhibit or do they cause optic nerve damage that is part and parcel of glaucoma? In other words, are we making glaucoma worse? So one of my strategies is to lower intraocular pressure more religiously in those patients before they get injected. So I do try to take steps with topical therapies to lower intraocular pressure in advance of my procedure.
How about cataract surgery? So there's a few people who have asked, is there any downside to cataract surgery if you have wet AMD, or are there additional risks?
Well, there always are additional risks to any surgical procedure. We know that in patients that are less than 75 years of age, cataract surgery has a tiny, small but incremental risk of retinal detachment, as Dr. Campochiaro mentioned. And that risk is probably cumulative. It's probably less if one is over 75. As far as one of the things that we do to monitor neovascular AMD and dry AMD is various forms of non-invasive imaging using so-called OCT, scanning ophthalmoscopic laser technologies. And those scanning lasers that have to go, those little lasers that are like ultrasound bouncing light off the back of the eye and giving us an exquisite image of the retina, have to go through the lens, the cataract. And if the cataract is sufficient, it will degrade that image. So, patients with severe cataracts benefit tremendously from having their surgery, because then they see better and we see better. So we're better able to look after them. That's my perspective on it. But I think one of the things I do is I don't tend to inject someone inside of a month of their procedure. So we try to time the procedure so that they're having an injection, and then next week or the week after that, they can have their cataract procedure, and then a month after that, they can have their injection again.
That's really interesting. I hadn't thought about that before, like the actual getting to the back of the eye and being able to see through the cataract, because I imagine that cloudy film would make it very difficult to see through.
Well, it's a good way to tell how bad the cataract is. I mean, if you get a great image,
Yeah.
and some patients are told they have cataracts, and yet I'm still getting exquisite images. So really, in that situation that the cataract isn't causing the vision trouble. But other times it's the opposite. So.
No. So someone else had asked about high myopia. So myopia, I guess being like distance or like poor distance vision. Does that have an effect on AMD, especially if it's like severe?
Well, pathological high myopia has different definitions, but generally speaking, it's an axial elongation of the eye. So most authorities would say if one has an axial length of more than 26 millimeters from start to finish, from the beginning to, then one has what is known as pathological myopia. Those folks are at risk as they age of a dry form of macular degeneration. It's not AMD, but it is myopic macular degeneration, and they also can develop neovascularization or abnormal blood vessels. It's more and more prevalent, especially in Asia. The predictions are that more than 50% of the world's population will be myopic, not necessarily highly myopic, but myopic in the coming years. So myopia has become almost an epidemic in the world, and we're going to see more of this, not less, going forward.
And how about, I think lastly was diabetes. So I know in diabetes, it can cause a similar effect to wet AMD, where there's extra bleeding of the vessels in the eye and causing leaking. So how do those two conditions interact?
They can overlap. Patients with diabetic retinopathy, need to be monitored very, very carefully going forward. And the three main indications for these proteins that Dr. Campochiaro was discussing, the injections of antivascular endothelial growth factor proteins, which are the current therapy that we use for wet AMD. That's also the three main indications are swelling in the retina from diabetes, neovascular or wet AMD, and swelling in the retina from vascular occlusion in the retina, which is also related to hypertension. So those are the three big areas. So in fact, sometimes if patients have an underlying level of dry AMD in association with diabetes and macular edema, they're going to benefit from the injections in any event. There's a crossover benefit there. So, but there are ways to parse out through these imaging techniques that I've mentioned, which is which. We can figure it out which is the main cause of vision trouble. Is it the diabetes or is it the macular degeneration? We can figure that out.
With diabetes, and again, correct me if I'm wrong, but like good sugar control would probably help with minimizing that.
Yes, it's very important. I mean, I think sometimes people beat themselves up, though. I mean, I say it's really about mileage, right? I mean, it's mileage on the odometer. If we've had diabetes for 20 years, it's different than having it for 5, and we're more likely to see those kinds of organ-specific complications if one's had diabetes for 20, 25 years. But yes, inside of that window, the steadier one can keep our blood sugar, the less likely we are going to see those complications.
So we had a question here in the Q&A from Julia, and they said that they'd had an injection 7 years ago for wet AMD, but they've been told they don't need treatment other than an annual visit to their doctor. So they're wondering, how do they know, or what kind of symptoms would they need to be aware of in order to seek treatment again?
Well, that's very interesting. It's I think what I would always cover one eye, maybe once a week, or there are strategies that one can use. The problem is if we're trying to test our vision with both eyes open, we can compensate for if we start losing vision in one eye slowly, our brain sort of compensates. So you've got to cover one eye, cover the other eye, and check for how straight are the lines. You can look at a window frame, you can look at a door frame, you could look at an Amazon grid, one of those little pads of paper that your eye doctor can give you, and look for any curvature or distortion of those straight lines. And that usually is associated with either fluid under the retina or fluid in the retina. And, that should lead to, having someone look really soon into your eye to make sure that the fluid hasn't come back or that there hasn't been bleeding under the retina and so on. But what I tell my patients is just to keep an eye on and usually people get pretty good at it, in terms of being able to tell.
Also just monitoring any changes in your vision. being aware of what. So we've had a few questions. We've mentioned a few different medications for injections today, and someone's asking about Eylea, Lucentis. We talked about Vabysmo. Are there any drugs that are better, or does it depend on the patient?
Well, I think it does depend a lot on the patient. I mean, we're seeing the other thing we're seeing is biosimilars coming as drugs come off patent. Lucentis is coming off patent or is off patent, and there are several biosimilars. And I think that those drugs have been tested and found to be good. So I think that the doctors that are prescribing for individual patients, what I tend to do is like start with sort of a ladder of therapy, and what we've always been hoping is that some of the newer drugs would have longer durations of action. And I think that the one thing about Vabysmo is that it does seem to have a longer duration of action, perhaps not as long as advertised, but certainly longer than the original, drugs did. So one of the advantages of moving from Lucentis or from Beoviz or from Avastin to Vabysmo is possibly getting a longer duration of action. And in diabetic retinopathy, as Dr. Campochiaro said, it's a bispecific antibody, so it's also working against angiopoietin 2, which is a factor in diabetes more than it is in AMD. So it's getting to be complicated. It's getting to be, yeah.
Can you comment a little bit more on biosimilars? So, what is a biosimilar and what advantage, disadvantage does it have over one of the other drugs?
Well, I think that they're entering the marketplace mainly because of cost. I mean, as the on-label therapies come off patent, there will be biosimilars developed, which are very similar. But the thing about biological drugs, the reason they're called biosimilars and not generic drugs, is because even batches of Lucentis, one batch of Lucentis to the next batch of Lucentis to the next batch of Lucentis are slightly different because they're biological drugs. And so that's really what they're talking about, is these biosimilars are made to be as close to the original drug as possible, but they're never going to be identical. Even the original drug varies from batch to batch. That's the point.
I have another question here about, this is going back to one of the previous questions. Is myopic AMD significantly different from wet AMD?
Yes, it is. It's not, I wouldn't call it myopic AMD. I would call it myopic macular degeneration. And it can be in both a dry and a wet form. And if we talk about the neovascular or wet form of myopic macular degeneration, it tends to have a better natural history than AMD. And one reason it does is because the underlying pigment epithelium that Dr. Campochiaro alluded to, one of the layers, the deep layers, the pigmented layer of the retina, is more healthy in myopic patients than it is in AMD patients, and is more able to envelop the abnormal tissue and seal it off. So, patients with myopic macular degeneration often do very, very well with anti-VEGF therapy because there's a little bit more of a natural ability of the eye to heal itself, and so we're aiding and abetting that natural tendency of the eye to heal itself. So I'm very hopeful in my patients with myopic disease that we can help them and keep them stable for many years. So, and I have a lot of patients who've been treated with anti-VEGF with myopia, and we've been following them for years and years and years and years, and they've not had recurrence, and they've kept good vision. So I think it's quite a hopeful situation.
Thank you. So I have one more question here from the chat from Harry. He says, my father's getting injections for wet. After an injection, he had an unfortunate complication. It sounds like his retina detached and he has lost some vision in that eye. He's still getting injections every 6 weeks in his other eye, but understandably, he feels like things aren't working and he's nervous that he's going to lose his sight in his good eye. Do you have any recommendations or thoughts for Harry or his dad?
Well, unfortunately, he had a very rare complication of the treatment. The one I fear the most is actually endophthalmitis or an abscess in the eye from an injection more than detachment. But detachment's rare and does occur. It I think it one way to mitigate the risk would be to say, okay, if the good eye is looking perfect at the 6-week mark, would it be possible to go a little longer? So what I do is I follow a treat and extend approach where patients who are in that situation, who are on a level playing field, if we're happy with the endpoint, happy with vision, happy with the appearance of the OCT, no fluid, no fluid in the retina, no fluid under the retina, no blood, then we might add a week or two each time. So I assess them, I look in their eye, I look at the OCT, measure their vision, and we talk, and we basically keep extending the interval. So what that does is it reduces the number of injections per year that the patient is subjected to, and by doing that, you're reducing risk, right? So you're balancing the risk of recurrent disease against the risk of causing any kind of rare complication. So I've got patients now who, are several years out, but they're still getting 3 or 4 injections a year, and they're quite happy with that because it keeps everything on a level playing field, and we still monitor them closely.
Thank you so much, Dr. Cruess. As per usual, we always have more questions than we have time for, so I really appreciate all of your answers. Those were great questions, so thank you also to our audience members for sending them in.
Thank you.
So
Thanks for the opportunity to chat to you.
it was great.
today.
So yeah, a huge thank you to Dr. Cruess, Dr. Campochiaro, and of course, Mo Lalani for joining us today. It's been such a great discussion.